Welcome to Summarize Science. Have you ever been talking to an AI chatbot and it just keeps asking questions, or maybe it gives you an answer way too quickly? It turns out, one of the biggest challenges for AI is knowing when to stop thinking or asking questions. Stopping too early can lead to a wrong answer, like diagnosing a panic attack instead of a heart attack, as shown in this paper's example. But stopping too late wastes resources and can even confuse the AI. Researchers from Carnegie Mellon University have developed a fascinating new training method called CART to solve this very problem. The first key ingredient of their method, called CART, is something called hard negative counterfactuals. That sounds complicated, but the idea is actually quite brilliant and intuitive. They train the AI by showing it a pair of almost identical conversations. In the first conversation, stopping at a certain point leads to a correct answer, so the AI is told terminate. But in the second, they change just one tiny piece of information, like the answer to the last question, which now makes stopping a bad idea. In this counterfactual, or what-if scenario, the AI is told continue. This forces the AI to learn exactly which pieces of information are critical, rather than just learning simple patterns like stop after 5 questions. The second ingredient is verbal reasoning. On top of deciding whether to stop or continue, the AI is trained to generate a short explanation for its choice. It has to reason, in plain English, about why the information it has is either sufficient or insufficient. This is like thinking a problem through out loud to check your own logic. Combining these what-if scenarios with self-explanation teaches the AI to build a much more robust and reliable understanding of when it truly knows enough. So, does it work? The researchers tested it in 2 different areas. First was interactive medical diagnosis, where an AI doctor asks a patient questions. As you can see in these graphs, the models trained with CART, shown in orange and blue, achieved a higher diagnosis success rate than other methods. Crucially, they often did this after asking fewer questions, meaning they were more efficient. They also tested it on AI models solving complex math problems. Here again, CART significantly outperformed the baseline models. The CART-trained AI got more answers right while using fewer computational thinking steps. This shows the approach is effective for different kinds of tasks, whether it's interacting with the world or just thinking internally. So, let's recap the big picture. This research introduces a powerful way to make AI more efficient and reliable by teaching it a simple but profound skill, knowing when to stop. They accomplish this by training the AI on counterfactual, what-if scenarios, forcing it to learn what information is truly critical. They also have the AI verbally reason about its decision, making its internal process more robust. What could this mean for the future? Imagine more efficient AI assistants, more reliable medical AIs that don't waste a doctor's time, and smarter systems that solve problems without running up huge computational costs. It's a huge step towards creating AI that isn't just knowledgeable, but also wise. Thanks for watching Summarize Science, and we'll see you next time.